This was a test on random roots and fractional exponents, also known as rational exponents. And we are going to be exploring that topic now. If you have a pencil in your hand, shame on you. Put the pencil away, watch the video, learn what you need to learn, and then go back and do the problem yourself. Preferably after a delay. You know, maybe watch a few videos and then go back and do a few problems at a time. Copying off of me will not teach you how to do the problem. Okay, you never know until you do it yourself, if you really know it or not. Alright, so evaluating this should be pretty straightforward. We have the fifth root and then it's squared, and we had access to a table. So let's consult the chart for the fifth root of 16,807. So fifth root 16,807 is 7. So that means right here inside the parentheses we have 7. And then of course 7 to the second power is 49. So that would be your answer to number 1. Similarly, looking at number 2, the third root of 512. Okay, third root of 512 is 8. So this will become 8 to the fourth power. Alright, so now we look at the chart and see what is 8 to the fourth power. 8 to the fourth power is 4,096. So the final answer here will be 4,096. Alright, how about number 3? Seems like the same thing. The fifth root of 100,000. To the chart. Alright, the fifth root of 100,000 is 10. So that this will become 10 to the third power. And of course 10 to the third power is 1,000. So the final answer to number 3 will be 1,000. Alright, how about number 4? Okay, well this one is written in exponent form, but we know that in exponent form the numerator is the power and the denominator is the root. So we could quickly rewrite this as the second root or square root of 36 to the third power. Now we don't need a chart for this one. The square root of 36 is 6. So then we just have 6 to the third power. And I'm pretty sure that is 216. 6 to the third power is 216. So that is the final answer for number 4. Notice that the second root, the 2 is understood. So you don't write the little 2 right here on the radical. It's understood to be 2, but keep that in mind. Alright, how about number 5? Number 5 has a negative exponent. And the way I like to handle a negative exponent is that negative power means we have to drop this entire thing into the denominator. So this will quickly become 1 over negative 512 to the 1/3 power. Alright, we've dealt with the negative now. So now we just need to do 1/3 power. Well, remember this 3 is the root, and power of 1 is irrelevant. So this really is simply the cube root, well, 1 over the cube root of negative 512. So this will become 1 over the cube root of negative 512. Okay, let's see. So we're going to have 1 over. Now the cube root of a negative number is just a negative number. Alright, the cube root of 512 is 8. So the cube root of negative 512 is simply negative 8. So this will be the final answer for number 5. Okay, and number 6 is back to just a normal problem. So cube root of 125, is 5. So then this will become 5 to the 4th power, and 5 to the 4th power is 625. So that will be the answer to number 6. Number 7. The easiest way to deal with a fraction that has a negative exponent is to do the reciprocal of the fraction and make the exponent positive. So 1 over 4, the reciprocal is 4 over 1, but of course 4 over 1 is just 4. Okay, so 1/4 to the negative 2 power is the same thing as 4 over 1 to the positive 2 power, which of course is 16. That's the most efficient way to do number 7. Number 8. Since all of the bases are the same, they're all negative x, we can simply add all the exponents. So this would be negative x to the, see, that's 8, 9, 10, 11, 16 power. Okay, so we have negative x to the 16 power. Since this is an even power, this negative is going to cancel out and go away. So the final answer would just be x to the 16th power. Alright, if this had been odd, like 15, then we would have put negative x to the 16th power. But you can't leave any parentheses. Alright, now this one. Because there are no parentheses around this negative sign, this negative sign is not being raised to the 4th power, okay? We're just doing the 4 to the 4th power and then sort of multiplying by negative 1. But anyway, when you look at this, look at it this way. This negative sign is doing its own thing. It might as well be way out front. So then we just have 4 to the 4th power over 4 to the 4th power. And of course, anything divided by itself is 1. So this part is just going to be 1. And then we just have that negative sign. So the final answer would simply be negative 1. Okay, looking at number 10. When you multiply with like bases, you add the exponents. So this is going to be x to the, and then we have to do 2/5 plus 1/2. Okay, you add those exponents. Now to add fractions, you need like denominators. So off to the side somewhere, let's just do, we're going to do our 2/5 plus 1/2. Let's make both of these denominators into 10s. So we will multiply by 5s over here, and we will multiply by 2s over here. So that'll give me 4/10 plus 5/10, which makes 9/10. I don't know why I'm putting a box around that. How about a circle instead? So that's what's going to be happening right here. So when I have x to the 9/10, then this is where that came from. And that's it. That's the final answer for number 10. Since we started out in exponent form, we will leave this in exponent form. No radicals. Alright, number 11. We have to do the 4th power. So really, we're just doing the 4th power to everything. So, you know, I'm doing 3 to the 4th power. When I do these variables, though, please understand I'm multiplying, so it's like I'm doing 3/4. Focus on this right here. Okay, focus on these. I'm doing 3/4 times 4 here. So let me just show you this off to the side. You don't need to write this down, but you should be doing this in your head. Sorry for clearing my throat so much, but 3/4 times 4. The way I think of it is, because this is like 4/1. These 4's just cancel each other out. Okay, so it's just going to be 3. Alright, that's the most efficient way to think about it. Like, these cancel each other out. Now, if you don't like that, then you're probably one of those who like to think of it this way. 3 times 4 is 12. And then 4 times 1 is 4. So then 12 divided by 4 is 3. Alright, either way you get the same thing, but your way is longer, so my way's better. Sorry. Anyway, x to the 3rd power. Now, same thing with the y's. Now, if you did this my way, you would go, okay, 2 goes into 4 twice. And then that leaves -3 times 2, which is -6. Alright, that is the most efficient thing to do. Alright, now, but if you insist on doing it the long way, then you're going to do -3 over 2 times 4 over 1. And that's going to make -12 over 2, which is -6. Same result. Okay, so now we've got this. As you know, anything with a negative exponent is going to get dropped to the other side of the invisible fraction. Alright, the 3 to the 4th and the x to the 3rd is going to stay in the numerator. Instead of 3 to the 4th, let's go ahead and put 81. We've got a table, let's use it. 3 to the 4th power is 81. And but also my x to the 3rd power is going to stay where it is. But this y to the -6th power is going to drop down and become y to the 6th power. So this is the final answer for number 11. Alright, now number 12. We're always looking for what part is the same. So in this case, notice that the exponents are the same, 1/3 and 1/3. If the exponents are the same, and only if the exponents are the same, we can go ahead and divide these. Now this thing that is the same will stay the same. So when we're through dividing, we will still have 1/3 power. We're not going to do anything with the 1/3. So obviously 60 divided by 10 is 6. So we will have 6 to the 1/3 power. And that's it. We can't reduce this in any way. So we started off in exponent form, so we're just going to leave it in exponent form. So it'll just be 6 to the 1/3 power. Okay, number 13. Now, first of all, anything with a negative exponent needs to move to the other side of the fraction. So this y to the -2 power is going to move up. Everything else is going to stay right where it is. So I'm just going to recopy this problem unchanged. So the 16 still there, x to the 5th power still there, y to the 7th right where it was, 4. Okay, x to the 0 power. Alright, right now I'm only making one change, and that is the y to the -2 power is going to come up to the top and become y squared. Everything else stayed right where it was. Now I'm going to simplify stuff. Okay, now 4 goes into 16 4 times. So this 4 goes into 16 4 times. So for that reason, in the numerator, now I have a 4. Now let's deal with the x's. Well, x to the 0 power is 1. So this becomes a 1, which I don't need to write down. So that just is going to leave my x to the 5th power unchanged. Now I will deal with the y's. These are on the same level now, so we just will multiply by adding these exponents. So this will give me y to the 9th power. Now everything's in the top, so I could put a 1 down here, but we won't leave a 1 in the denominator, only in the numerator. So this is the final answer right here, 4x to the 5th power, y to the 9th power. How about number 14? How about that? So we need to do this 1/3 power to everybody. So I'm going to have 125 to the 1/3 power. I'm going to have x. Now here again, when I have a power to a power, I multiply. Now here again, if you do it my way, then this 3 is going to cancel with this 9 and make a 3. So I'm just going to have -3 right now. Okay, now if you couldn't keep up with that, and you were just like, what? What did he do? I don't get it. Then you will need to do something like this off to the side. -9 times 1/3 is what we're doing. You could look at it as -9 over 1 if it gives you comfort. The -9 times 1 is -9. 1 times 3 is 3. -9 divided by 3 is -3. Alright, which is where I got my -3 from. Just only a lot quicker. Doing the same thing with the y's, I'm multiplying here again. I'm doing 2 times 1/3. So that's going to give me y to the 2/3 power. And again, it's just 2 is like 2 over 1. So I'm just doing 2 times 1 is 2, and 1 times 3 is 3. So this is what I have so far. Alright, I don't need this anymore. Alright, now obviously anything with a negative power is on the wrong side of the invisible fraction. Okay, so this is going to have to drop down. Alright, but the 125 to the 1/3 power, that's going to stay up, as is the y to the 23rd power. So let's see what I have. So I said this is going to drop down. So I'm going to have x to the 3rd power in the denominator. The y to the 2/3 power, that's going to stay up there. So there it is. Now look, off to the side, if necessary, we're supposed to remember this this 3 in the denominator is a root, cube root. So 1/3 power is the same thing as the cube root of 125. So we must simplify this. The cube root of 125 is 5. Alright, maybe I should have written this first. 125 to the 1/3 power is the same thing as the 3rd root, which is 5. Now you should know that by heart by now, but if you didn't, the cube root of 125 is 5. So that means I can replace this expression with 5. And this will be my final answer for number 14. Alright, now how about number 15? Cube root of stuff. Well, how about the 16? Let's look at that first. Now, we're dealing with cube root, so I'm going to look at the 3rd power column. 16 is not on the list. So instead, I'm going to look for something that divides into 16, the biggest number I can find. 8 is on the list, and it does divide into 16. For that reason, as I break this down, 16 is 8 times 2. So I will rewrite this as 8 times 2. I'm putting 8 in pink because it is something that can be reduced, simplified. I can take the cube root of 8. in a minute. Now, in a similar way, I need to break up my x to the 5th power. For variables, I need these exponents to be divisible by the root. So this needs to be divisible by 3. 5 is not divisible by 3. But I can split this up as x to the 3rd power, which is divisible by 3. But that leaves 2 x's left over. In other words, x squared. So I've taken my x to the 5th power and I've broken it apart as x to the 3rd and x squared. I wrote this part in pink because I can simplify it and bring it out of the radical. Now, y to the 15th power, I like it. 15 is divisible by 3. So I don't have to break it up. I do not need to change it. So I will leave it as y to the 15th power. Now everything here in pink is going to simplify and come out of the radical. So the cube root of 8 is 2. The cube root of x to the 3rd power is x. I'm doing 3 divided by 3, which is 1. And the cube root of y to the 15th power is 5. Because 15 divided by 3 is 5. So that takes care of all the pink stuff. Now the blue stuff just stays like it is. Under the radical and such. So I will have the cube root of 2x squared. And that will be the final answer for number 15. Okay, we were supposed to choose 2 of the next 3 problems to solve. These are the 3 problems that gave some of you fits because they required you to actually think for yourselves a little bit. There will always be a few higher level thinking problems on every test. These problems will not be identical to problems that we've done in class because any problem that you've seen the exact same problem before, there's no way it can be a higher level thinking question. A higher level thinking question requires you to take what you already know, the principles that you've learned, and apply them to a slightly new situation. And that's what these 3 problems are meant to do. Now, having said that, these are 3 of the easiest higher level thinking questions you will ever see. But they are the most important problems on the test. All right. A lot of math, you might ask yourself, when will I ever use this math in life? And depending on your career choices, you may never use a lot of this stuff. But what I'm trying to do, in addition to just teaching you how to solve math problems, I'm trying to teach you how to think creatively. And problems like this, if you can think creatively and solve this type of problem, you can apply that anywhere in life. All right, you can solve any kind of problems if you can get your mind to think elastically and creatively, outside the box. Anyway, enough of my little speech. Number 16. If I want to create an expression involving both positive and negative exponents that simplifies to this, okay, I mean, there's an infinite number of ways to do it, but here's the simplest one off the top of my head. For example, say if I had a to the 20th power over b to the negative 7th power. Boom. Okay, this could be one possible answer right here. Because obviously the first thing you would have to do is go, oh, this has a negative exponent, so this would have to go to the other side of the line. So then that would give you a to the 20th times b to the 7th power. So that's about as easy as I could make it. I could make up more complicated ways of giving me the same thing. For example, let's see. Just looking at the a's. Say if I had a to the 22 power over a squared. What would happen here? Well, you know, these two a's would cancel out two of these a's, and so that would leave a to the 20th power. So there you go. Now, so what if I had, hold on, what if I had b to the 5th power? Alright, because I have to get some negative exponents in here as well. So what if I had b to the 5th power, but then down here I had b to the negative 2 power? Right? Here again, this would get it done, right? Because this negative b to the negative 2 power would have to come up and become b to the positive 2 power, and then that would make 7. That would make my b to the 7th. So this would be another example. So those are just two examples, but I mean I could go on and on and on with you know, there are millions of different ways to make this happen. So I'm just going to write examples. What did I say before? Simply a to the 20th over b to the negative 7th. Alright, let's see what's next. Create a radical expression that simplifies to 8x to the 7th power y to the 3rd power. Okay, a radical expression. Now, so you had to know what a radical expression was. Alright, so that's something that involves one of these. Or, you know, it could be the cube root or 4th root or 5th root, any kind of root you want. I'm going to go with square root, just because why not? I mean, it's really simple. If I want to get 8, you know, the square root of what is going to give me 8? Well, 64. Alright, square root of 64 is 8. Okay, if I want to get x to the 7th power, what would I have to put in here? Well, guess what? I'd have to put x to the 14th power. Okay, because remembering that square root, we would have to divide by this invisible 2. So 14 divided by 2 would be 7. So that would, you know, x to the 14th power would get it done. So what about the y's? What kind of y do you think I'm going to have to put here so that I would wind up with y to the 3rd power? It would have to be y to the 6th power. Again, if I divide by the invisible 2, that's understood. 6 divided by 2 would be 3. So this is one, and we don't put the 2, but this is one example that would give me 8x to the 7th power y to the 3rd power. But you know what? Let me do one more with a cube root. Okay. So let's see. I mean, again, there are many examples, but if I wanted to do a cube root expression, so really just working backwards, let's see, what is 8 to the 3rd power? Let's look at the chart. Let's see, 8 to the 3rd power is 512. Okay, so if I put a 512 here, then that means the cube root of 512 would be 8. Alright, looking at the chart, you know what I mean? Cube root of 512 would be 8. So I could do this. Now here again with the variables, I'm going to need to divide by this 3 and get this. So if I had x to the 21 power, divide by 3, you get 7. If I had y to the 9 power, alright, divide by 3, you get 3. So I'm just going to stick an etc. on here. But so these are two examples that would simplify to this. But you know, I could go on and on with other powers and stuff. Alright, number 18. Find 3 different values for a, b, and c such that the 4th root of a times c over the 4th root of b will give me 25. Okay. So A, B, and C, they can't all be, they can't repeat. But let's go ahead and let B definitely equal 1. So let's see, we have A, B, and C. There's no reason why we can't let one of them be 1. So if B is 1, then we can kind of forget about that because the denominator, if B is 1, that makes the entire denominator a value of 1. So far that means we just need to concentrate on the fourth root of A times C, and that has to give us 25. Okay? So let's just work backwards. Now here's the key. Whatever's under this radical has to simplify down to 25, right, when we take the fourth root of it. So in other words, imagine that we had, imagine that we had 25 to the fourth power. Alright, 25 to the fourth power, 4 divided by 4, it would give us 25. So whatever's under this radical has to have the value of 25 to the fourth power. Or in other words, it has to have the value of 25 times 25 times 25 times 25. In fact, I'm going to need a bigger radical. Alright, because whatever's under this radical has to be 25 times 25, 4 times. Now, you did not have access to your TI-30XS multi-view. But you did have access to a 4-function calculator. So even on that, you could do 25 times 25, hit enter, and then do times 25 a third time, hit enter, and then do times 25 one more time. Okay, so this is what you would get if you did 25 times 25. Get out of there. If you did 25 times 25 4 times, you get 390,625. So that's the value of what has to be under this radical. So 390,625. So in terms of what A and C have to be, A and C have to be anything that you could multiply together to get this big number. So the easiest way to figure out what that is to divide. I'm betting that this is divisible by 25. Well, it kind of has to be because it's 25 to the fourth power. So let's just divide this thing by 25, and then we'll have it. Okay, so I'm taking this and I'm rewriting it as the fourth root. Let me just draw a line here. So I'm having the fourth root still. But instead of having this big number, I'm going to rewrite it as 25 times whatever else. So if I take this big number and I divide by 25, then I'm going to get back to here. Okay, so 15,625. 15,625. So this could be my A and my C, 25 and 15,625. Alright, or anything else that could multiply together to give me this number. It doesn't have to be this. But just as an example, A could be 25. Alright, B could be 1, and C could be 15,625. Okay, and if we had that, if we had that in this expression, you can just see what would happen. If I did the fourth root of this, if I put in my A and my C, like I said, then I would get this number. All right, of course, the fourth root of 390,625, looking at it on the calculator here, obviously you didn't have access to this calculator, but I'm just proving to you that it works. So let's see, the fourth root of 390,625. All right, that would give us 25. Okay, so just like we knew, would give us 25. And then having b be 1, we'd have the fourth root of 1 is 1, so we'd have 25 over 1, which is 25. So this would work. This was definitely the harder of the three, so if I were you, I would have chosen 16 and 17, because 18 was a little bit more challenging. Alright, let's move on to number 19 and 20. These are the ones where you're supposed to find an error, if there is one, and fix it. Now let's see what we have here. From this step to this step, I see they went ahead and looked at this as -2 and positive cube root. There's nothing wrong with that. Alright, the cube root of 125 is 5, so that's 5 to the -2 power, nothing wrong with that. Alright, here's the error right here. Okay, error. If you take the fifth root, not the fifth root, if you take 5 to the -2 power, instead of getting -25, this -2 simply drops you down to the denominator. So it should be 1 over 5 squared, which equals 1 over 25. Okay, so that should be your correct answer, 1 over 25, not -25. Okay, so that was it for that one. Alright, how about number 20? Let's see what happened here. Alright, so they simplified. So the fourth root of 32. Alright, well, 32 is not on the chart. So they had to split it up with a 16. Now, I'm going to show the step in between the way I taught you. So this should equal, so I've got 7x squared. Now I'm going to split this up like we do. So 16 is on the chart, not 32. So that's why I'm going to split this up into 32 is 16 times 2. Okay, now this x to the 9th, I really need something that is divisible by 4, so I'm going to split this up as x to the 8th with one extra x left over. Okay, so everything shown here in pink is going to simplify and come out. So the square root of 16, let's see if I can color code this a little bit. So the square root of 6, I'm sorry, not the square root. The fourth root of 16 is 2. Okay, and so that's where this 2 right here is coming from. Now, x to the 8th power. 8 divided by 4 is 2. Okay, so that's where this x squared is coming from. So far, so good. That should leave behind 2 and x. Well, there's my 2 and x. And of course, the 7x squared that was in the front, that's still there. So, coming to this step, there was no error so far. So far we're good. After this, all we're supposed to do is multiply everything together. 7 times 2 is 14, that's good. But x squared times x squared should be x to the 4th power. So there's the error, is right there. So I'm just going to circle this and say error. Okay, there was my error right there. That should have been the fourth power. So 14x to the fourth power times the fourth root of 2x. All right, that's it for number 20. What else you got? All right, number 21, a factoring problem. Well, what is the first step of factoring, my children? We know that the first step is to bring out the greatest common factor, GCF. If I do that, then I will have x squared minus 9x minus 36. Okay, I'm just dividing everything by 2. Alright, so far so good. Now I need to factor this further. X squared will just be x times x. 36 has many possibilities. 36 is either, it could be 6 times 6, or it could be 4 times 9, or it could be 3 times 12, or it could be 2 times 18, or it could be 1 times 36. A lot of possibilities. Now we're looking for the option that will help us get a negative 9 middle. So the most promising option is this one right here, 3 times 12, because 12 minus 3 is 9. So let's go with that option. So if this is going to be 3 times 12, now we need a negative 9 middle. Okay, so right now inner we have 3x, outer we have 12x. To get a negative 9 middle, we need a negative 12 and a positive 3. So there's your negative 12 and there's your positive 3. So this is what we're looking for, 2 times x plus 3 times x minus 12. And that is option B. So there you go. Alright, number 22. What is the end behavior of this function? Now the key part of this, one of the key parts is the degree. This is odd. All odd degree functions have the same type of end behavior. So we might as well consider the end behavior of a cubic function, like x to the third power. This is your basic model for the end behavior of a cubic function. Notice how this reminds you of a capital letter N. Alright, this is the positive version. The other thing that can happen is we can have sort of an upside down N shape for a cubic function. And this would be the negative version. Okay, sort of have the end behavior like an upside down N. So this is how odd degree functions will work. So we know it's going to be one of these end behaviors in terms of the model. Now, since there's this negative sign in front, that tells us we can forget about the positive version and just focus on the negative version of the end behavior. So basically, on the left side it rises, and on the right side it falls. That's what should be happening. Now, looking back at this end behavior, as x approaches negative infinity, well, that's your left side. Okay, and on the left side it rises, so the function approaches positive infinity. Let me make that a little bit better. I said positive infinity. Alright, it's only slightly better. Anyway, this positive infinity, this is the right hand side, and as we said before, as we go to the right, it falls on the right. So as x approaches positive infinity, the function approaches negative infinity. It falls. Okay, now that is a beautiful infinity. And that is it for this problem. Please understand that a fifth degree polynomial like this one doesn't actually look like this. This is the graph of a cubic function. A fifth degree function would actually look more like this. Okay, with an extra, see, there's your cubic, and then there's your fifth degree. Okay, so it's going to look more like this. But the important part is the end behavior. Regardless of the extra hill in the middle, the extra turn, on the left it rises, and on the right it falls. Okay, all odd degree works that way. Okay, let's move on to number 23. Finding the inverse. Now, finding the inverse of a matrix is a two-step process. Okay, so step 1, and I'm going to call this matrix A. Okay, and by the way, this negative 1 power means find the inverse. All right. But the first step is to find the determinant. Alright, the determinant of matrix A. Now, the way you find the determinant is you just do the down diagonal minus the up diagonal. Okay, so here my down diagonal is 10 times 3 minus the up diagonal, which is 2 times 8. Okay, so in other words, that's going to be 30 minus 16, which is 14. So this is the determinant of the matrix. Now, save that for later. We're going to need it for step 2. Now, in step 2 is where we reverse negate. Okay, now when I say reverse negate, again, I'm referring to the down diagonal and the up diagonal. We're going to reverse the down diagonal and negate the up diagonal. So if we do that, so reverse the down diagonal. So I will have 3 and 10, like that. Now if I negate the up diagonal, I will have negative 2 and negative 8. So we have to reverse negate and divide by the determinant. Okay, which was 14. So there, I did my reverse negate. Now to show that I'm going to divide by 14, I'll just put 1 over 14 in the front. But just remember, this 1 over 14 just means to divide everything by 14. So if I do that, then I'm going to have 3 over 14 and negative 8 over 14 and negative 2 over 14 and 10 over 14. Okay? So all I really have to do is reduce all these, and then that will be my final answer. So 3 over 14 does not reduce, but then we'll have negative 4 over 7. Alright, I'm just reducing that. And we'll have negative 1/7, reducing that. And we will have 5 over 7 if I reduce this. Okay, so this is the final answer. Just to review, if I wanted to find the inverse, all I needed to do is I need to reverse negate and divide everything by the determinant. That's the bottom line. Okay, last problem, number 24. Well, clearly we want to solve the system using the elimination method. We already have opposites, so we don't even need to multiply by anything. We just combine like terms. 8x plus 5x is 13x. Alright, these of course cancel out. 20 and negative 7 make 13. So if I want to find x, I can just divide both sides by 13. Alright, so that is going to give me x equals 1. Now we still need to find y, so I'll just put a line. I'm just going to use the bottom equation, so that'll be 5x plus 6y is equal to negative 7. If x is equal to 1, then that'll give me 5 times 1 plus 6y is equal to negative 7. Such as 5 plus 6y is equal to negative 7. Alright, subtracting 5 from both sides, that'll give me 6y is equal to negative 12. And then I'm just going to divide both sides by 6. So that'll give me y equals negative 2. Or I could write this as an ordered pair and put 1 comma negative 2. Alright, that is the end of this lesson. I hope it has been helpful. If you're practicing up for a test, if I were you, I would make sure I could do this entire test from start to finish on my own. So go back, print out a blank copy of this, or maybe just use a sheet of scratch paper and redo this entire test without watching the video. If you can get all the answers right, then you're ready. Alright, see you on the next video.